Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. In this revision session on Euclidean geometry for you grade 12s, I would like to bring some of these revision session as students are requesting to kind of have some more on these sessions, and I just quickly wanted to bring you this question, and I will be quick also to say, guys, apologies for the poor sound. There is a noise in the background. It's raining today, but I thought of since it's actually it's a Friday today, and I wanted to just bring you some content that you might actually use during the weekend. And look at this question, 10.2. It's a Euclidean geometry question, and I haven't kind of prepared my notes fully for Euclidean. That's why I just wanted to bring these revision sessions, but it can also work to your advantage as you are revising. It says in the diagram, O is the center of a circle and PQS and R are points on the circle. P is equal to Q. PQ is equal to QS, and angle QRS is equal to Y. The tangent at P meets SQ approaches to T. OQ intersects PS at A. Let's look at this diagram. So we are given this diagram. It says here we've got a center O, and then P, Q, S, and R are points on the circle. You can see them. PQ, I think they also marked it here. PQ, if you look at this, PQ is equal to what? Is equal to QS. Look at that. Those two are equal. I think you can see from these lines that the approach is there. And then they are also saying here, and then angle QRS, there is that angle here. It is equal to what? The angle is equal to what? There. The tangent at P, it says the tangent at P meets SQ, so we have got SQ produced to T, so there is the tangent there, see the tangent, and then OQ intersects PS. They say OQ, there is OQ, it intersects what? PS at A, so there is that point there, there is the A there. Alright, so this is the question, guys, and what this is the statement, and what are the questions here that are following? It says give a reason why P2 is equal to Y. Now P2, let's study this thing. P2, why P2? Let me identify P2, and you can see that P2 is formed by this line here. Look at this. We have this line and we have that line. That is what forms here P2. Are you seeing that? If I can have a thick line here, just look at this, and this is a chord. If you can look at this chord, and I also have another line here, look at this, suspended by the same chord. So what I'm having here, it's more like I've got a line like this, which has got that and that. See that? And then we are saying that angle is equal to that angle. Angles subtended by the same chord. So the question here they are asking is give a reason why P2 is equal to Y. So here you are going to say angles subtended by same chord. So that's the reason. It's the angles which are subtended by the same chord. Right, but you can also simply say these are angles in the same segment. Also, it's also proper angles in the same segment. Why? Because it's on the same segment. From the line that is blue, so it's angles in the same segment. So that's the reason there. And then the next one says prove that PQ bisects TPS. So you have to prove that PQ, let me erase this part again, because it's very important for you to keep sketching or seeing some of these the theorems in between.
So it says prove that PQ bisects. What is to bisect? Is to divide the angle into two equal parts. So we have got the angle TPS, which is T, P, and S, right? So we have got that, and then they say prove that PQ. So if I can have this angle, this one, you see that. So if it's a bisector, it means this P2 is equal to what? P3. That's what they're saying. So we are proving that angle P2 is equal to angle P3. That's all that you're trying to prove. A bisector is a line that divides the angles into two equal parts. So now, how can you go about that? Now, look at this again. There is a hint here. They told us that PT is a tangent, right? They said the tangent at P meets SQ projected to T. So this is a tangent here. So if it is a tangent, now always when they give information, always try to ask what is the reason behind that information. Now let's think about the tangent and the radius to say, will it give us any hints? It's not gonna give us anything because there is an extra angle that we're adding here. All right, so let's leave the tan perpendicular to radius theorem. But now let's look at the tan chord theorem. That's the next one that you can use where it involves the tangent. Remember the radius. So if they give me a tangent, I'm thinking, is it the tan perpendicular to the radius? Where you do that, and you're saying this angle here is what? Is 90 degrees, right? But it seems like it's not gonna help me much. But what about the tan chord theorem? Look at this. With the tan chord theorem, it's possible if I draw the line here, right? And I draw the line here, and I draw the line here. Now, let me just remind you of the tan chord theorem here to say, if I can have a circle like this is my circle, and then I have a point here, and I have a line which is a tangent that touches that. Remember that. So now if I can then have, say, have that, and then have that, and then have that, a triangle. So now from that, if I can have this particular angle here which has this line, see that? So that particular angle, if it's X, now from this angle, look at the triangle formed. I've got here, let's say I've got A, B, and C. So there must be a triangle that is formed. So from BC already is the line of interest. It forms that angle. So ignore BC. Look at the opposite angle. That particular angle is equal to also X. That's what we mean by the tan chord theorem. So you can do it the other way around, opposite the other way around. If I say, have a circle again, right? I'm having a circle, and then I've got a tangent to that circle. Anyway, picture a tangent. The moment I draw a triangle, like a line like that, and then I say, what will this line be using the tan chord? It means I must form a triangle. Remember, a triangle has got 3 points. Already this is A, and then that is B. The moment I form the third point, see that, which goes back to A. In that third point, C, the angle formed, you see, don't use AB because AB is the line of interest, but the point which is the opposite. So that angle formed, if this is theta and that is theta. So now using the same concept, look at this. If we look at this triangle, at this tangent, I can extend it to that. And then if I extend it and then I say, look at the angle here. So my line of interest is already this. You can ignore that line. But look at the angle formed. So this is my P. This is my Q. What is the third point? It's my S. So now if you look at that line, is equal to this line. Do you see that? So which means I can conclude there and say angle P3 is equal to angle S1. What is the reason? The reason is tan chord theorem. It's the tan chord. So if we agree that that is that, now something interesting. How many marks is this thing? Let me see. It's 4 marks. It makes sense. Now we know that P3 is equal to S1, but again we have got some interesting information here. Look at this. If you look at S1, they told us something interesting about these two lines. Look at this line and look at this line. What do they say? They say these lines were equal. There is that. So if these lines are equal, then you have the base of that line. Look at this line, the base. And these base angles, so what you have is more like you have got a line like this. Right? And if this is equal to this, you know also this angle is equal to that angle. So if this is A and this is B and this is C, you know that angle B is equal to angle C. What is the reason? These angles are opposite equal sides. Angles opposite equal sides. So even here, you look at this angle, it means here that angle is equal to that angle, meaning S1, again let me write that, it means S1 is equal to P2, and then what I'm gonna say, it's angles opposite equal sides. Alright, which equal sides we have to now mention to say what are the equal sides here. PQ is equal to SQ. It's given, remember, PQ is equal to SQ. So now if these angles are equal, then we can conclude. Actually, it's done now. They said prove that PQ is a bisector. Now look at this. We can say therefore, now P3 is equal to S1, right? And S1 is equal to P. So if S1 is equal to P, I mean if P3 is equal to S1, look at this, and at the same time S1 is equal to P, therefore you can conclude that P3 is equal to what? Is equal to P2, right? And then which is equal to what? Which is equal to Y. So we said S1 was equal to P2. In the first question they said P2 is equal to Y. So you can even conclude here and say here Y is equal to S1, which is equal to P2. Okay, so P3 is equal to P2, which is equal to Y. They gave us actually that angle, right? So we can come back here and say if this angle is Y and that angle is Y, that's what we mean about a bisector. It divides the angle into two equal parts. Then you can say therefore PQ is a bisector. You conclude that. Of what? Of that angle TPS. We are concluding that, and then you get your 4 marks for that. Alright, that is that. Let's continue the question. Then the next one says determine POQ in terms of Y. POQ in terms of Y. Now look at POQ. POQ like this. So what they want is that angle. Remember, O is the center. Now if I take that and I give you that, now you tell me. You come back to the theorem. Remember the theorem here. If I have an angle, okay, let's have my that, and then I've got my center O, and then with my center O, and then I have another line that goes there. You remember that point? Okay, let me do it properly because I'm just doing everything around. Let's do it here. Let's say I've got my circle, which is center O, and then I've got that, and then I have another line like that goes back to that point. What do you say? That angle is twice that angle. Angle at center is twice the angle at the circumference. I can even draw it here. Look at this. Draw it there and draw it there. It's still the same. Angle at center is equal to angle circumference. Now we know that this angle is Y. So if this angle is Y, this angle is 2 times what? 2 times Y. So the question was determine POQ in terms of Y. So POQ is equal to 2 times Y, which is equal to 2Y. Are you seeing that? That gives you what? 2 marks. Now, not the last one, then says prove that PT is a tangent to the circle that passes through points PO and A. Let me check that. Prove that PT, let's remove that. They're saying prove that PT that PT, that line PT, is a what? It is a tangent to the circle that passes through the points P, O, Q. So let's look at the circle there. There is a tangent that will pass through P, O, and what they say there, let me just check. That passes through P, O, A, not Q. P, O, and A. Look at this. So you've got this kind of a triangle. So they are saying there, if you are to draw a circle, there is a circle that is passing through these points like this. It's a circle. Then they are saying that prove that this particular, of course, is not done properly. They're saying the moment I draw that particular circle, it's going to be a tangent, but that circle will pass through there and that circle will pass through there. So that P is a tangent. Again, look at this. We actually have a tan chord theorem. Now look, I have got that point, which is point 1. Look, there is point 1, there is point 2, and there is point 3. Now I said whenever you're talking about the tan chord, remember my line of interest is this one. Right? The moment I do that, I will say this particular angle, right, which is in this case it will be P2 plus P3. So P3 plus P2, it is this angle, remember, that is formed, is equal to that particular angle, which is equal to what? Which is equal to angle O. Now let's find out what is our angle O. Remember we said our angle O was 2y in the previous question. And then what is P2 and P3? We did establish, they told us that this is a bisector, so that this angle is y, that angle is y. So which is y plus y. So in this case 2y is equal to 2y. Are you seeing that? So now if we're saying that, then it shows that this actually angle, the question is prove that PT is a tangent. Then you can say therefore PT is a tangent, and then what's the reason? Is the converse. It's not the tan chord. Now we are using the converse of tan chord. That's what you use. You use the converse of tan chord to say if this angle is equal to that angle, then it's the tan chord that you're applying, and that tan chord you're applying, it shows that this line is a what? Is a tangent. All right, and then question number 5. Let's look at question number 5. Then question number 5 says, prove that OAP is equal to 90 degrees. OAP. So they're saying if I take my line, I do that, and then I do that, and then I do that. This is a right angle triangle. They're just saying this is 90 degrees. That's what they're saying. I must prove that that is a 90 degrees. Now, okay, how do we go also about that? But let's use the information already that we've been given. We have been given that this angle is y, that is y, this is y, and that is already y. And we know that this is what? This is 2y. Are you with me? Now, if that is the case, now, if I've got a triangle like that, I'm interested in finding out what is that, because I have to prove that, I'm trying to prove that this is a 90 degrees, remember. So if I can find that angle, then my life would become a little bit easier. But now look at this. Something interesting is to, let's focus on this. If I draw a line, make me thicker, like this one, and this one, and this one. Now, you will agree with me that PO is a radius and QO is a radius from the center. So again, we can use the concept which says those angles are equal. Remember, angles opposite equal sides. So we can actually then use the concept here that says, look at this, I can write in and say, that was, remember this was 1, this was 2, this was 3. I mean, actually this is the other way around. This was angle 3 here. Let me erase and bring it back. You see, it's 1, 2, 3, right? So we are saying in this case, angle P1 plus angle P2 is equal to what? Is equal to Q2. You see? Why? We are saying angles opposite what? equal sides. But you need to tell us which ones are the equal sides. Then you're going to say in here, you tell us that PO is equal to QO, which is equal to radii. So it's 2 OP is a radius and PQ is, OQ is a radius. So now that we have established, look at this. If we agree that P1 plus P2 is equal to Y, but we know what is P2. P2 is Y, remember, we did that. So now with that, to know that P1 plus angle P2 is equal to Q2, now these angles are equal. Now if I can have my triangle, let's look at this triangle now. Look at this. I'm just having this triangle in here. That triangle is O, this is P, and this is Q, and that is the Q2. Remember we said this angle is equal to that angle. But in this angle, remember there is 1 and 2. Look, I know that this is 2y, right? And I know that these are equal. Remember the radius? These are equal. It's the blue one that I'm drawing. It's the same as the blue one. Now, I can know what is the sum of angles in a triangle. That's the first part. Remember, sum of angles in a triangle is equal to what? 180 degrees. So if I can say angle O plus angle here, it will be OP, which is O. Let me remove here. If I say angle O, and then I've got P, and then I've got Q, see that? Plus angle Q2. What must give me? It must give me 180 degrees. These are what? Sum of angles in a triangle. Sum of angles in a triangle. You agree with me? But I know what is my O. Remember, O is 2y, so I can say 2y plus my OPQ, which is this one. I don't know that, but I know part of it, which is OPQ is this. If you combine these two, you get your OPQ. Are you getting it? So which is P1 plus P2 plus Q1 plus Q2 is equal to 180 degrees. Are you with me? But at the same time, I repeat again, we know what is Q2. We said Q2 is P1 plus P2. So I can come here and say 2y plus P1 plus P2 again plus P1 plus P2. You see that now for Q is equal to what? 180 degrees. See what I'm doing? But now we come back, we know what is P2. There is my P2. Remember, even the question they said prove that P2 is equal to y. So I come here and say 2y plus P1 plus P2, which is y, plus P1 plus P2, which is what? Which is y, is equal to 180 degrees. Then it's a matter of simplifying now, whereby what are you going to say? You're going to say 2y plus y, which is 3. Okay, 2y, let me collect like terms here. 2y plus y plus y, that plus that plus that, and then plus P1, that is an angle, plus P1, which is an angle, is equal to what? 180 degrees. I think that. And then this become what? 4y. 2y plus this is 4y plus 2P1 is equal to 180 degrees. Take 4y to the other side. What will I have? I will have 2P1 is equal to 180 minus 4y. And then I divide by what? By 2 on this, divide by 2. Then what you have is P1 is equal to, now it's better to separate this division so that you can know the answer. So the 2 is dividing on each of them. So which is equal to 180 over 2 minus 4y over 2. I see what is happening there. And then P1 becomes what? That becomes 90 minus 2y. I think that's my P1. It's 90 minus 2y. Now the question was what? The question was, let's go back to the question. Prove that OAP is 90 degrees. We are proving that this is 90 degrees. So now I'm back again to my diagram. Let's do this. let's draw this diagram separately. We are looking at now this new diagram like this, right? And they are saying we need to prove that that is 90 degrees, like that. If I can have it like that. So what is this? This is my P, this is my O, and this is my A. I have to prove that is 90 degrees. Now we just proven, now this is the P1, remember, that's your P1 now. Now we know that this is 2y, right? And then sum of angles, again we continue, sum of angles in a triangle add up to 180 degrees. So what am I going to add? If I add P1 plus O plus A, it must give me what? Actually P1 plus O plus, if I just add, if this is to be a right angle, it means P1 plus O must be equal to 90 degrees. Right? So what is P1 plus O? If I take P1, we say P1 is 90 minus 2y. So if I say 90 minus 2y and plus O is what? Is 2y. What does it give me? It must give me 90 degrees. So there you can see that 90 degrees is equal to 90 degrees. Therefore, okay, here what I'm gonna say, sum of angles, this is sum of angles in a triangle. Now therefore you can conclude then and say O A P is equal to what? Is equal to 90 degrees, because the other two are 90 degrees, therefore this one definitely will be equal to 90 degrees. But the key part here was to recognize the two radiuses, which were this radius and that radius, and understanding that if I add this sum of angles in a triangle, they can give me 180. Just in a quick way, I think there was something much quicker there to do. You could have just done this. I think now that I'm working on it, then this becomes what? Remember, this we know is 2y, and we know that if I have this line, these two angles, it's easy to know them. Now sum of angles in a triangle, so I was going to say angle, for example, angle P, what is that? P O, let me call it O, PQ was equal to 180 degrees. Remember? I'll just do this. I'll say angle PO, not angle PO, angle OPQ plus angle O plus Q2, we just did this, they must give me 180 degrees, right? So I can just focus on this guy to say, what is this angle PQ? It is equal to what? 180 degrees minus O, which is what? Which is 2y. But we know that these two are equal, so it's 2 times that. I think that then you divide by 2, you divide by 2. Then you're going to say that particular angle O PQ is equal to 90 minus y, because 2 will divide that to give you 90, and 2 will divide that. You must make sure that you divide twice to give you y. So it's 90 minus y. So if you know that this angle is 90 minus y, but you know that this one is simple y, I think that. So now if you want to find this one, it will be 90 minus y, you see that, which is equal to 90 minus 2y. That was one way. Then from there you continue that. And another thing that also, if you can also look carefully into this whole structure, look at this. If I have this diagram, I've got that and I've got that, and then I've got that. If I can have my line here like this, do you see what I'm having? I'm having kind of a rhombus, here, but you can call it even a kite, where the diagonals are what? The diagonals are perpendicular. This is of a kite, you know. This is a kite where the diagonals are what? Are perpendicular. Why do I call it a kite? I cannot say it's parallel lines, but I can use this to say we know that this is equal to this, and we know that this is equal to this. Why? Because it's the radius. OP is the radius, OS is the radius. This PO and PQ and QS is given. So this is a kite. If this is a kite, the diagonals of a kite are perpendicular. So you can say in here OQ is perpendicular to PS, and then you can call it reason diagonals of a kite, right? And therefore A is equal to 90 degrees. Just that, if you could have done that, I think they'll give you also full marks. So guys, these are different ways you could have approached it. As I said, apologies for the noisy background, but I just wanted to bring this to you.